Alright, so we're going to do a transformations overview. I feel as if when we did the flipbook, it was just a little too much graphing and not enough focusing on what the actual transformations are. So, when we go through, let's talk about how many types of transformations there are. So, there are 3 types of transformations that are called rigid transformations. Alright? This means that after the object has been transformed, the pre-image, which is the original figure, and the image, which is the one after we move it, will be congruent. So again, rigid means that they will be congruent all the way through. So we have a translation. So when we're doing a translation, we talked about it before, a translation is actually just a slide. Okay? Or you're going to push it somewhere. Okay, so you're either going to move horizontally, or you're going to move vertically. Now you can also do both at the same time, which, as you'll see next, the symbolic notation for that looks like this. So you take your x-coordinate and you either add or subtract a number, and then you take your y-coordinate and you either add or subtract a number. Okay? So that plus or minus just means that you can either add or subtract. Now, when we're looking at x values, when it says plus for your x values, remember x values only move horizontally, so horizontal, just as a reminder. So if you're going plus horizontally, that means to move to the right, whereas minus means that you must be moving to the left. Alright, now y values is talking about moving vertically. That means up or down. So plus, when I'm talking vertically, means to go up, and minus means to go down. Alright? So what we have here is already plotted for you, how nice, right? Is telling you right here to take this square that says x plus 7, and we'll do a different code, and we'll do y minus 4. So, what we have here is x plus 7 means, remember plus and horizontal, so that means right 7. And then minus 4 means down 4. Okay? Now personally, when I'm moving a lot, it's kind of hard for me to tell. So my counting is not always the best. So what I'm going to do is I'm actually going to take the x coordinates and I'm going to add 7 to all of the x coordinates. So pause for just a second and I want you to do that. Add 7 to all of the x coordinates. So pause. Alright, so that should be all of our x values added by 7. Alright, now what we're going to do is take all of our y values and subtract by 4. So pause again and we'll subtract all of our y values by 4. There we go. So now all we have to do is plot it. So I'm going to just pause again. So if you want to press pause real quick, we're going to plot it really quick. Alright, we won't do a lot of that today, but if you want to go ahead and pause. Notice everything is the same shape, and if I could draw straight lines, they would look identical, just slid right and down. Alright, so for the next one, all we're going to do is decide which way did it go. And we're going to try and make sure to use our notation here. So remember we have our notation, our prime notation. Okay, so prime notation here, this apostrophe, okay, that means that it is the second one. So that means our original is right here, and I can actually just focus on one dot. So let's focus on K. I want to know how do I get from K to K prime. That's how we're going to figure out what we need to do for our rule. Okay, so when we do that, we would say, all right, so here we are at K. I need to go to K prime. So if I do that, I go 1, 2, 3, 4, left 4. So that's an X thing. So left 4 means X minus 4. All right. And it looks like we go up. So 1, 2, 3, 4. Okay, so up 4. So Y, and then up is plus, and then 4. All right. Sounds good. All right, let's move on to reflections. So reflections is just a flip. All right, so we have a flip over a line called the line of reflection. All right? So we'll mirror everything on one side and the same as the other. Okay? Okay. So now what we're going to do is it says flipping over vertical lines. So vertical lines, the most common one is the y-axis. Y-axis is up and down, right? Goes like this. Wonderful. Also, any line that begins with x equals any number is going to be a vertical line as well. So it says x equals 7. That means go to the right 7 and draw a vertical line right there. So the process is to determine how far away each point is from that line that you created or if states, and repeat on the other side. Now it'll be the same exact thing for flipping over horizontal lines. The most common horizontal line is the x-axis. All right, and it looks like this. I'll write it right here. And it says also any line that begins with y equals. Okay, because y equals tells you go up or down to this spot right there, and then you're going to go through and just draw horizontally right there. Okay. Now, when you look at the next one, the next two are the hardest ones, but if you can write this down and make sure to keep using it, I think you'll understand. So, when it says flipping over other types of lines, the line y equals x. So the line y equals x actually looks just like this. So, I'll draw a picture real quick right here. The line y equals x actually goes through the origin. Okay, I'll change color so you can see it a little better. It's this line right here. Okay, going through the origin, the slope of 1. So if you're flipping over that, what you'll do is you'll just switch x and y. Okay? So for example, an example might be, let's say the example is the original is 1, negative 3. That will turn into negative 3, 1, because they just switch. Okay, now we did the line y equals negative x. So that would give you this line right. So here's your axis. And it's the exact opposite. So it would look like this. The line would be going down, slope of negative 1. Okay? So what you'll do is you switch x and y and change their signs. Okay? So for example, I would have negative 4, comma 3, and that would change to negative 3, comma 4. Wonderful. Okay? Alright, now let's move on. So, what we're going to do is graph and label each figure and its image under the given reflection. So, I'm going to pause really quick and I want you to go through and I want you to draw in all of the parts where it says reflect over. So, I'm going to highlight the x-axis, I'm going to highlight x equals 1, I'm going to draw in y equals x, and y equals negative x. Okay, so pause. Alright, so all we're going to do here is we just want to go through and see how far away each letter is, and we want to go on opposite sides. So I'm going to start with B because it's the easiest one. B is one notch below, so I'm going to go one notch above. That's B prime. Okay, now I'm going to do the same thing with C. C is 2 above, so I need to go 2 below. And then A is 1, 2, 3, 4, 5, so I'm going to do the same. 1, 2, 3, 4, 5. And that's A prime. Now we've done it. Okay, now for this one, when you're going through and doing it, when you see the x-axis, I can actually just go through and I can read off my ordered pairs. So it looks like it says A, B, C, so I'm going to change that and make sure it says A, B, C. Okay, very well then. So we have A, B, C, and what we have is we're going to go negative 1, 1, B, just kidding. Okay, B is negative 1, 1, because that's the one I was looking at first. A is negative 3, negative 5. And C is negative 5, negative 2. Alright? So now let's look at x equals 1. So I just need to notice how far away it is for each point. So if I'm at the pink, I go 1, 2, 3. Okay, so I'm going to go 1, 2, 3. That's R prime. person is also 3, so I'm going to go right down here and go Q prime. All right. And then P is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And then we're on the same vertical line, so I'm going to go here. This one is P prime, and this one is S prime. Okay. So what we have here is we're just going to write down the ordered pairs. So ignore the pink line now and just tell me what ordered pairs are there. So here's the origin. So 1, 2, 3, 4, 5, 6, 7, 8, 2. So 8, 2. Q is 1, 2, 3, 4, negative 1. R is 4, and then 1, 2, 3, so 4, 3. And S is at 8, and then 1, 2, 3, 4, 5, 6. 8, negative 6. Okay? Now we're doing these. What we're going to do is I'm going to take the order of pairs. This one is not easy to count how far away they are. So I said y equals x means to switch y and x. So switch, or switch x and y. So let's do it. We had negative 3, 7, so this new one is 7, negative 3. K prime is negative 2, 3, so we're at 3, negative 2. And then L prime will be 1, negative 5. Now we just need to plot it. So I'm going to press pause. Go ahead and plot. Okay, so what we're going to do now is we're going to look at the next one. Remember I said that y equals negative x means switch x and y. And change sign. Okay, so A was negative 1, 2. So that means 2 goes here. 1 goes here, and switching their signs, this was negative, so it goes positive, and 2 changes to negative. Perfect. And then we have negative 5, 3, changing and switching. And then this one goes, oh, how interesting, negative 4, 4. It's the same dot. When it lies on your line of reflection, then it actually stays in the same spot. All right, go ahead and plot it. Okay, and there we go. That's all plotted. So rotation is a turn. So rotation means to turn. A turn centered around the origin. We can turn our paper clockwise, like a clock, or counterclockwise. Alright? So you just need to pay attention to which way they tell you to go. Alright? So now let's go through and we'll talk about 3 common types of rotation. So, the common types, we have a 90-degree rotation. That's moving exactly 1 quadrant. Okay? 180 is exactly 2 quadrants. And then 270 is exactly 3 quadrants. So most of the time on the SOL, they'll just ask you like how many degrees it is. You won't actually have to do it yourself, but it'll want to know how many degrees did you rotate and which way did you go? And is it a rotation? Okay? So I'm going to go through and I'll show you what this looks like, okay? But most of the time what they'll do is they'll ask you what kind of rotation it was, okay? So what we're going to have to do is we're going to have to actually locate, or we're going to be able to move our papers, okay? So I'm going to have to move just the figure because I can't move my whole screen. But please pay attention very carefully. So it says rotate 90 degrees counterclockwise. 90 degrees is 1 quadrant, and it's saying counterclockwise. So we're going to hop right here, okay? So we should end up in that starred quadrant right there. So give me just 1 second. All right, so now we're good to go. So we want it to go there, all right? So because we know we want it to go there, most of my figure right now is in the right top of my picture. Okay, so it's in the right top. So what I'm going to do is I'm going to start with this quadrant that I know that I want it to be in, and I'm going to rotate my paper until that starred quadrant is in the right top. All right, stop. We're in the right top. So I'm going to go through and I'm going to just plot it as if it were normal. So what that means is this is my normal way of plotting. So I'm going to go 2, 2, to the right 2, and up 2. Okay? And that's L prime. I'm going to go 6, negative 2. So I'm going to go 6, 1, 2, 3, 4, 5, 6. I'm going to go negative 2, 1, 2. All right, so that's M prime. And then it says 5, 3. So 1, 2, 3, 4, 5, 1, 2, 3. So N prime. Okay, now we're going to go through and just draw it in. All right. Oops, wow, that was bad. Okay. All right, so I'm going to pause. All right, and now I'm going to rotate it back. All right, now I've done my rotation. So if I want to write my order of pairs, I'm just going to write where they are in relation to my now normal, again, coordinate plane. So L is, here's the origin. And we're going to go 1, 2, 3, 1, 2. So negative 3, 2. All right. M is over here. Okay, so I'm going to go 1, 2. 1, 2, 3, 4, 5, 6. So that's positive 2, positive 6. Okay. Then N prime is located at, here's the origin, so 1, 2, 3, 4. 1, 2, 3, 4, 5. That's negative 4, 5. All right. So I'm going to allow you to practice with this second one. I'm going to pause and have it completed for you. There we go. Now this one is just a little bit harder, only because we went through and we had to make sure that, so A and B were in one quadrant and B and C were in the other. So I said focus on A, so I really just focused on this one the entire time. So I noticed it was in the left top. So when I rotated, I made my starred quadrant go in the left top. Then that's how I plotted the rest of it. Okay, now let's look at the next part. So what it asks us is just wants to know what is the rule. So how far did they rotate? So when you're doing rotations, there's always two answers. You could do either way. You could go clockwise or counterclockwise. So there are two answers here. So for this one, we're going to focus on just doing the clockwise one. So this one we'll do clockwise. All right. So if there's multiple choice, they only give you one answer that was correct. Okay. So there are always two, but they'll only give you one option as the correct one. So for clockwise, we need to think we're going like a clock. So we're going to jump over here. That's 1 90 degrees. And then another 90 degrees, and then another 90 degrees. So this would actually be a rule of 270 degrees clockwise. All right? Whereas if I had said the other, I'll just say it quickly, if I had gone the other way, counterclockwise, it's just one jump. That would be 90 degrees. And I'm going to put C for counterclockwise. Okay? This time we're going to go counterclockwise. So in the second one, we're going to go, oh, geez. And the second one, we're going to go counterclockwise. So counterclockwise means opposite of a clock. Okay, so we'll go opposite. Okay, one that way. And another one that way. Oh, 3 again. Okay, so this one is 270 degrees. But it's counterclockwise. Okay? Now for the next one, dilations is actually a very good one. So it's pretty easy to notice that a dilation is the only transformation where the pre-image and the image are not congruent. All right? So what actually happens is they turn into similar figures. So similar figures instead. Okay? They will end up being similar. To perform a dilation, you must multiply by the scale factor, which we used back when we were learning about similarity. All right? A whole number or a number bigger than 1 actually is, a whole number greater than 1. So actually it should just be a number greater than 1 because it can be a fraction. Okay? So a number greater than 1 means that your figure will get bigger. And a fraction, or a number smaller than 1, means it will get smaller. So what we're going to do here is we're just going to take our ordered pairs, and all you're ever going to do is you're going to multiply by whatever number they give you. They said k equals 2. So I'm going to take all my numbers in my ordered pairs, and I'm going to multiply them by 2. I'm going to pause, and you all right, and I'm actually going to go ahead and skip plotting it, but it would get bigger. So if I plot that, it would be much bigger. Actually, I'll just do it. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. For 6, that's 3, 4, 5, 6. And then negative 2, 1. Oh. This is negative 1, negative 2. My apologies. Negative 4. Okay. Negative 2, 1, 2, 3, 4. This is S prime. Wonderful. So we're going to plot it, and you'll notice that it's much bigger than before. It's doubled its size. So here, when you have 1/2, you can either think about it as multiplying by half, or if you find that hard, you're just going to divide by 2. Okay? You're going to take all of your numbers and divide by 2. So I'm going to pause. Now, I know you're probably not a huge fan of letter F's coordinates or the ordered pair, but it's actually very easy to plot. So when we plot, we go 0, 2. So 0, 2 is C prime. Okay, 2, 6. So 2, 1, 2, 3, 4, 5, 6. That's D prime. And then 6, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. That's E prime. And then 4. 1, 2, 3, 4, and then just down halfway in between, so F prime. And then here is our reduction. So you won't ever have to plot these on the SOL, but what they'll do is they'll ask you what happened. So for example, in this picture here, it's asking you what happened when I went from the first one to the second. So first you have to identify which one is the first one. The first one is the one with no apostrophes right next to the letter, so this is the first one. Okay, usually I just pick one letter to look at. So first of all, once I know that one is the first one, I know that this one has gotten smaller, which means I'm going to have a fraction as my k. As soon as I know that it's a fraction. Now I just need to know my ordered pair. So it's going to go 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. So this is 8, 4. And this one is 1, 2, 3, 4, 1, 2. So my question is, what happened to go from 8, 4 to 4, 2? I divided by 2, which means a fraction with 2. Now we're going to do the same thing here. This time, this one is the original, but ours is getting bigger and enlargement. So what we're going to do is we're going to look at where our axes are. That's actually right here. Wow, how weird. Okay? And I'm actually not going to focus on D, because that one might not be the easiest one to do because it's on the axis. So I'm going to pick I. So I go 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 3, 9. Okay? And that changes to, let's look at I prime. So it goes 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. My apologies. This one is actually 5. So this is 3, negative 9. Oops. It turns into 5, negative 15. So what you do when you have one that you don't really know how to get from one to the other is you can write them as a fraction. So what we'll do is we'll talk about the fact that we go from 3 to 5. So if we want it to get bigger, we're going to write it like this. 5 over 3. That is our scale factor. K is 5 over 3. And I could look at my y values as well. I would just need to go through and simplify. So it could look like this. Negative 15 over negative 9. But that actually simplifies to 5 over 3. Wonderful. That's all. Thank you.